Thanks everybody for being here. I'm Armando Fox, but you probably already knew that. And the pattern of the semester is usually such that you are never going to be more excited about this class than you are right now, because it's the first day of the semester. So my goal is not to lose you. I will do everything I can to make this a really fun experience. Yes, go join your friends, it's all good. I will do everything I can to make this a really fun experience. And I was going to start out with something that I'm going to bring back every lecture or two called Armando's Computer History Minute. And I do want this class to be as interactive as it can be, given that we have a lecture format. Does anybody recognize the woman in the picture? Sir? Margaret Hamilton. Did anybody else get Margaret Hamilton? And if so, would somebody else care to explain what is noteworthy about Dr. Hamilton in the field of software engineering? Anybody? Bueller? That reference doesn't work anymore. Did you want to elaborate, or shall I take it?
Computer worked on the Apollo guidance system.
The Apollo guidance system. Thank you very much. So let us watch a short YouTube clip to get the ball rolling. And what you're listening for is alarm. Let's see if this works. Why? Hold on. Let me move this. There we go. All right, now it'll work. Everybody hear that little clip? 1201 alarm. I assume everybody knows what's going on in this clip. This is the first time that human beings ever landed on the moon. And the guidance computer in the Apollo spacecraft was indicating an alarm that it had basically run out of processing power. What had happened was that one of the astronauts had left one of the external antenna dishes pointed in the wrong direction. So as they were trying to maneuver down to their final landing, the antenna was essentially picking up garbage. The guidance computer was trying to parse the garbage. It didn't have enough cycles to both do that and monitor the real-time landing maneuvers that Neil Armstrong was trying to do. So it raised an alarm saying, I'm going to discard the lower priority task of parsing garbage so that I can concentrate on the higher priority task of not crashing into the surface of the friggin' moon. And the innovation that Margaret Hamilton came up with, which allowed that to happen, was the idea of dynamic priorities. Until that time, computers that were doing different processes simultaneously, multiprocessing, were essentially round-robining with static priorities among them. And she came up with basically the insight that in a real-time system where an emergency might arise that really required the computer to divert resources to a critical task required a different kind of scheduling mechanism. So besides that, she's credited for having invented the term software engineering. Software was the thing that made NASA realize that actually building hardware, as difficult as it is, was not going to be the bottleneck pacing item in future space missions. It was going to be the software. So we have Margaret Hamilton to thank for an innovation that really is fundamental to real-time operating systems now, the concept of dynamic priority scheduling. There's a photo. By the way, if you're interested in this sort of thing, I'm kind of a computer history geek. A NASA intern a couple of years ago started uploading all of the Apollo 11 computer source code to GitHub, so you can go check it out. It's in the public domain because you as taxpayers paid for it, or probably your parents paid for it. This is Margaret Hamilton as part of the MIT team that was in charge of doing all of the Apollo 8 software. She was one of the development leads, everyone clad in 1965 attire and probably watching carefully to make sure that their software is actually working all the way down. So I think that's kind of an intro to the first question that I have for you all, which is, you've all written code, at least I hope so, or it's going to be a sad, sad semester for you. But what is software engineering beyond doing that? What's the difference between what you are already doing, or programming, and software engineering? There's no right answers, but there are many, many wrong answers. I'm kidding. Go ahead.
The art of building things in a sustainable manner.
Building things in a sustainable manner. That's good. And maybe more specifically, building things that people who come long after you've left the project, might be in a position to take over. Anybody else? Distinction between what you do when you are sitting at home working on a hobby project or a course assignment versus software engineering. Another critical distinction. Here's a hint. Anybody? Sir? Probably working in groups, right? We are way past the point where sort of the lone genius shutting themselves up in a room with Red Bull is going to produce the next software breakthrough. Most interesting software that you want people to actually rely on is way too complicated for that. So working effectively as part of a team to do that is one of the most important things in this class. David Parnas, a very distinguished software engineer who's written a lot about software safety and how teams work together, has said that the main thing that distinguishes software engineering from programming is that it's multi-person development, so teams, of multi-version programs, programs that evolve over time, as opposed to you build it, you put it out there, and you're done. Anybody recognize this Turing Award winner? He's on the caption. But in case you don't recognize him, Fred Brooks led the development of the operating system software for the IBM 360, one of the machines that is really regarded as having changed the game for how we think about computer architecture, the programmer's view of a computer. The lessons that he learned from that in the book The Mythical Man Month should be required reading, I think, for everybody doing software. But he says part of it is combining separately written programs and making them suitable for use by the people who had not written them. I'm going to take suitable for use to also mean suitable for continued development. So before, we had someone here say doing things in a sustainable way. One aspect of sustainability is long life. And he rightly pointed out that even today, these topics don't receive maybe as much attention as they should in programming courses, hence software engineering courses. If you talk to people who do software engineering now and you ask them, who are your best software engineers and what makes them great? There was a survey done about 3 years ago at Microsoft, and kind of the high order bits that came out of that is that there's 4 clusters of qualities. There's personal characteristics. Good software engineers are passionate about what they do. It's not sort of just a job for them. They're data-driven, and they're improvement-oriented and open-minded. So they're open to the possibility that there's a better way to do something than the way that they've been doing them. They're also the kind of people you want to have on a team. They're there to help their teammates. They want to create an environment where making mistakes is OK, where putting crazy ideas forward is OK. Sometimes they call that a safe haven, or feeling like the team has a psychologically safe environment. We're going to try to get all of you to sort of get into that space, right? Everybody in this room is able to be a great contributing member of a software engineering team, and there are specific things you can do to make yourself the kind of person that others want to hire and want to work with. There's a cluster of technical skills. You have to know what you're doing. And part of that is coming up with creative thinking. Part of it is thinking ahead to what technical needs might we encounter, and is there something in my past experience that I can bring to this project to help solve those problems a little more elegantly. Most of these problems are not about learning new technology stacks, right? Nobody really cares which technology stacks you know. It's how quickly can you learn a new thing, come up to speed, and start contributing in a way where you can bring new ideas into a project from day one. And finally, when it comes time to make decisions, especially technical decisions, knowing who your organization is, not just your team and your company, but your customer. How does your customer work? What are the different levels of the situation? The customer has some needs. There are technical constraints. Sort of balancing some, what I'll call socio and technical aspects. So software engineering really is about all these things. And lest this feel like it's sort of way too touchy-feely and not enough about coding, there's a lot of great technical stuff in this class. But if you don't know how to bring those technical skills to bear with other people working on a team to produce an artifact, then software engineering is probably not going to seem like a lot of fun. So having said that, I hope that most people here are excited about doing that, because that is our goal. We want you to learn how to do software engineering in a disciplined way, in a way that's customer-focused, which is putting what the customer thinks is important first, not something you think the customer would think would be cool to have. We will use, by and large, Agile development methodologies, not because they are the best, but because, as you'll see, the kind of projects we're doing, software as a service, turn out to be a very good fit for Agile methodologies. So today is going to be kind of a whirlwind overview of what we're doing in the course, expectation setting, what you all should expect from the course, what I expect, what your predecessors, students who have taken this course before, what things they have found to be challenging, and we'll see how far we get.